started here. So let's go over an example or two. From 15 and then from 16. I don't need to go over this very much unless you guys have specific questions, but we've kind of already covered all the main stuff. So I don't know, let's look at 15G. What is the, so it's asking the cosine of negative 14 pi over 3. That one would be a little tricky to do in your head just because to visualize where that is not super easy. So first thing, is 14 small enough that we can count it off? I mean, yeah, if it said 200 pi over 3, that's way too much to count. 14's just, we can count it off. I want to show you though, especially if it's a bigger number, it's often a good idea to say, well, 14 thirds is 12 thirds plus 2 thirds. So this would be 4. That makes sense? Mm-hmm. So what you can do is think about how, well, negative 14 pi over 3 is the same as negative 4 pi over 3 plus an extra negative 2 pi over 3. Does that make sense why that would be useful?
Yes. Mm-hmm. Yeah.
Because 4 pi is just going to go, the first thing to keep in mind is it's negative. So the negative is that direction, right? This is the positive angular direction, counterclockwise. The negative angular direction is clockwise. So, but 4 pi though is just 1, 2 times around, 2 full rotations. Now let's continue going another negative 2 thirds. So 1 thirds, 2 thirds. So we'd end up right there. Does that make sense? Mm-hmm. So by the way, you might go, wait a second. Are you saying that negative 14 thirds of pi is pretty much the same angle as, if I went in the positive direction, what would this be? It feels me? No.
Oh, yeah.
I'm not saying those are the same number, but they represent the same position angularly on a unit circle. Yeah. Okay, so cosine. So do I care about the x value of this point or the y value? The x value. So what is that x value?
1.
Very close. Negative 1. So the answer to this question is negative 1. The goal for you guys is maybe not with a weird angle like that. That one's a little tricky, but is to pretty soon, say I gave you this angle though. So something to keep in mind, guys. It's still a little early to be doing these mentally. If you are able to do them mentally, that's good. But I'd like for you to get to the point where you can say, what's the cosine of 4 pi over 3? Visualize where you are in the circle in your head. Visualize that position, and then know that the x value is negative 1. Does that make sense?
Mm-hmm.
Yes. Let's look at 1 or 2 from the next page. We're going to keep it simple. We'll move on to 17 tomorrow, but if you're done through 16, you're caught up. You have everything. Let's look at one on here. I don't know. How about the secant of 10 pi over 3? The secant of 10 pi. Oh, sorry. I forgot to say the counting rate. I mean, for this one, I could have just counted. Wouldn't have taken that long to go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I could end it up there. So this one, 10 is such a small number that I probably just going to go like this. 1 third, 2 thirds, 3 thirds, 4 thirds, 5 thirds, 6 thirds, 7, 8, 9, 10. So, oh, wait a second. It's interesting. It's the exact same position as before. So, How do I get the secant? Very close. The reciprocal. Yeah. So one of the things you have to just know is that secant, that word, is the reciprocal of the cosine. So we actually just figured out the cosine. So we know the cosine of this is -1/2. What does that mean for the secant?
Negative.
Yeah, positive, or sorry, -2. Isn't that nice? Okay. Okay. Great. So, I don't know. Let's do one more. This should be a good one.
J.
Sure. So the cotangent. Is one more example sufficient, or do you guys want to? You guys feel like you get it?
Yeah. Yeah.
So the cotangent of -22 pi over 3. So start. I don't know. We could count that off pretty easily, or go. I think it's actually more interesting to, instead of counting it off, to go. Well, let's see. -22/3 could be written as what?
-7 plus 1/3, or -1/3.
Yeah. So -7 plus an extra -1/3. Does that make sense?
Okay.
It's like 21/3 with an additional.
Oh,
third.
right, okay.
Keeping in mind, though, that 7 pi would lend you where?
No.
If you want to visualize it, you might go, okay, 1, 2, 3, 4, 5, 6, 7. Okay, so that's -7 pi. And then you're going an additional -1/3. By the way, guys, I mean, I hope you've noticed that if you draw your picture in a relatively to scale way, it's pretty straightforward to see which is the short, which is the long side. Right? The short side would be -1/2. The long side would be the square root of 3 divided by 2. Are we all cool beans about that? Makes sense? Okay. So the cotangent, the tangent would be the y value over the x value, right? So the cotangent would be the x value over the y value. Make sense? Okay, and then so you could go, well, I've got -1/2 times 2/√3. The 2's cancel out. And you're left with the cotangent. Are there any questions? Okay. Okay, so you might not, I mean, you might be able to finish early. Yeah, tomorrow I'll go over the inverse ones. If you want to get a jump start on figuring that out, there's a little bit more to it than this, just a slight amount. But if you do want to move forward, it's as simple as, well, the core idea is as simple as this. Hey, what's the sine of pi over 6? The sine of pi over 6 is 1/2. So then could I say the inverse sine of 1/2 is pi over 6? So yeah, yes, you can. That's correct. So you could think about that. The only tricky thing is you got to think about invertible functions. There's a little bit of there's a little bit of stuff you got to do to make sure that the sine function is invertible. And that comes into play when you have stuff like, what's the sine of -1/2? What kind of angle would that give you? Would it give you a negative angle or a positive angle? So anyway, I'll cover it tomorrow. Yay? Yay, good? Yay!